Okay, girls, you have to say, I think this confused you as to what you actually had to do here, but you had to tick the box if it was injective or surjective or bijective. So remember, SLIM, slim. If it's surjective, it hits it at least once. If it's injective, it hits it at most once. So the first one hits it at least once, or sorry, for injective, it hits it at most once. It hits it at least once, and bijective is both, injective and surjective, okay? Right? The next one, G, it hits it at most once, no, right? Is it surjective? It hits it at least once, no, because there's lines down here, right? Okay, they don't hit it at all, and then it is not bijective either, right? Okay, sorry, can you see that spiral? I might get a gel one if I can, if I have one. This might be better, I don't know. And the last one, H, remember it's only R positive to R positive, okay? So you're only looking at you're only looking at this quadrant. Positive real numbers for the x's, positive real numbers for the y's. So if you draw any horizontal line, it will hit it at most once, it will hit it at least once, and therefore it's both, so it's bijective. Okay, 15 marks for that. Okay, right, and the next one is F after G. Right, okay, so that means you do G of x first. So G of x is equal to 4x minus 3. Okay, I'm conscious that it's hard for you to see, is it? Well, I tried the red biro, it might be better to see it. Can you see that? Barely, yeah? G of x, then you have to do h next, so then you have to do h of the answer. So you have to do h of 4x minus 3. It's a red better because it's a gel pen, yeah? No? Or is it wrecking your brain? Right, okay, so into h, everywhere you see an x, put in a 4x minus 3. Right, minus 1. Sort that out, that's 8x minus 6 minus 1, which is 8x minus 7. So then you have to put 8x minus 7 into f of x. So f of x means into x, everywhere you see an x, put in an 8x minus 7. So it's 8x minus 7 to be squared plus 2 times 8x minus 7. Sorting that out, square the first, 64x squared. Twice the first by the second is 112x. Square the last, plus 49. Multiply in here, plus 16x and minus 14. And that would be 64x squared minus 96x plus 49 minus 14 is plus 35. Okay, 10 marks for that. Is that okay? Are we good? Right, and you had to multiply it out and tidy it up because of this. Right, okay, so multiplying it out and tidying it up was part of the question. Okay, the next one then, okay, identify the following as injective, surjective or bijective. Right, okay, injective is at most once, right, so everything gets it hit at most once, right, so this is not injective because it gets hit twice, right, okay. Surjective is at least one, so everything has at least one arrow coming into it, so this is your surjective one. At most once, this is your injective one, and bijective is exactly once, okay, right, so bijective, sorry, oh sorry, that's what I need to do, yeah, so bijective, injective, surjective, 5 marks for that, okay. Calculate, so n equals RE, right, okay, I think girls, you needed to make a better job of this, okay, anyone who made a bad job of these log question, right? Or it was e to the or exponential question. The next bit is a log question. Girls, we did this in algebra, right? And it's nearly always on the paper. Okay, so you need to figure this out. Okay, so if it's a thing that you couldn't do, you need to sit down and figure out how to do it. You need to get a way to do it because it's not right. Okay, so look, there are 600 bacteria. N is the number of bacteria, so there are 600 bacteria. Put 100 into a nutrient agar plate, right? Okay, agar will act as a food source. So R is, wait now, what certain can be identified with the equation? A science teacher puts 100 into nutrient agar plates. Agar will act as a food source for the bacteria. 5 hours later, there are 600. Now, they didn't explain what R is. Okay, which is a bit, but yeah, they should have said R was the bacteria at the start. They haven't. Right, okay, so it's badly worded. It came off a pre-paper. You find that with pre-questions, they tend to be badly worded. It won't happen in the leaving cert. N is the number of bacteria that is there now, right? 100 is the number of bacteria that was there at the start, and it's e to the power of, K is what you're looking for, right? Okay, so K is what you're looking for, and the time was, oh yeah, 5 hours later, wasn't it? 5 hours later. Okay, is that right? Okay, it was badly worded. I apologise for that. Okay, right. There's 100 stuck to that. Okay, you can't do the logs or any of that until you just have e to the power of by itself. Okay, so you need to get e to the power of by itself. So that means divide each side by 100. So you get 6 is equal to e to the power of 5k. Is that alright? Okay. Then we need to, now you get the log of each side, the log to the base e, right? Or ln of each side. So ln of 6 equals ln e to the power of 5k, right? You can bring the power down in front. So ln 6 equals 5k times ln e. ln e is, remember ln is log to the base e, so log to the base e of e is what? 1. So that turns out to be 1, so you get 5k equal, yeah. So you get 5k equals 5k equals ln 6, and then you divide each side by 5 to find out what k is. So into the calculator you press ln 6 divided by 5 and you round it up to 4 places in the decimals, and the answer is 0.3584. Is that okay? Right, and as I say, girls, there's nearly one of those questions on the Leaving Cert every year. Right, so to mind our little class tests on the Leaving Cert. Right, so if you can't do it, you need to figure out how to do it. Because we've done it in algebra, and we did it again here. Okay, then over to this question. Marks for that, I didn't tell you, did I? Marks for that, I turned the page. It is 10 marks for that. Okay, 10 marks for that. Is that okay? Right, next one. Right, after how many hours, so this time we're looking for T. Right, will the number of bacteria in the plate be 10,000? So N equals R e to the power of KT is the formula. So N is the number of bacteria. You want N to be 12,000. R is the bacteria at the start, which is 100. E, you've just figured out E is 0. What was it? 3584, was it? 584. And T is what we're looking for this time. Okay? So before you do a log of each side, D has to be by itself. So divide each side by 100. So you'll get 120 is equal to e to the power of 0.35840. Right, okay. Now you get the ln of each side. So ln 120 equals ln e to the power of 0.35840. Then bring the 0.35840 down in front. Ln e equals 120. ln 120 even, right? Okay, and then ln e is 1. So to get t is equal to ln 120 divided by 0.3584. And when you work that out, it works out to be 13.36 hours. Now they didn't say how many decimal places, so I'd give at least 2, but I didn't penalise anyone if they went to 1 place of decimals because they didn't say. Right? Is that okay? Are we good? Right. The inverse, girls, right, okay, this is a procedure that you need to learn off. So you change the f of x to a y, right? Y equals 2x all over x minus 1. You're rearranging your formulas, so you've, instead of having y equal to all the x's, you rearrange it so you've x equal to all the y's. Okay? So cross multiply, so y by x, y minus y when you cross multiply there. Y by x is xy, y by 1 is y. This way 2x by 1 is 2x. So I want the x on its own. So there's 2 x's here, so I need to bring both to the left. So you get xy minus 2x. Yeah. Sorry. Equals y. Okay, take out an x and you end up with y minus 2 equals y, and then divide by y minus 2, so x equals y all over y minus 2. Now you're finished because x equals all the y's, so instead of y equal all the x's, you have x equal all the y's, and you change the x to f inverse of x, and we change all the y's back to x's. X all over x minus 2, and where is that? 5 marks for that. Okay? Are we good? Yeah. Can I go? Right. Okay. The last one then is two functions f and g. Given the function h of x equals g after f of x. So you have to do g after f of x, so that means you do f of x first. So f of x is equal to 1 minus x. Then you have to do g of the answer, so you have to do g of 1 minus x. So that's 2 times 1 minus x, 2b squared minus 9. Okay, please note here, you have a choice. Do you multiply by the 2 first or do you square first? And the answer is you square first. BIMDAS, do your indices before you multiply. So it's 2, square the first, twice the first by the second, square the last. Okay, minus 9. And then when you tidy up, multiply in, tidy it up, you'll get what they say you're going to get. Okay? Yeah, sorry, I knew I'd that done. Just, is that alright? So you have a choice here, square first or multiply by 2. BIMDAS says you square first, okay? Right, I shouldn't be seeing that mistake. Okay, so that's h of x, because they said h of x is the answer you get when you do that. Right, now they asked me to complete the square. right? So I'm starting with 2x squared minus 4x minus 7. Right, to complete the square, I have to have x squared by itself, right? I can't complete the square with a 2x squared. So I have to take a 2 outside the bracket, okay? So x squared minus 2x minus 7 over 2. Okay? Now, you ignore the 2 outside the bracket until the end. Okay? So there's a 2 outside the bracket, but I'm just going to complete the square in the bracket. So it's x squared minus 2x. Halve the coefficient of x. So halve that, you get 1. Square it, you get plus 1. But you can't just put in a plus 1, you have to put in a minus 1 and a minus 7 over 2 there. Right? When you factorize the 3 of those, it'll be x plus 1 to be squared. Okay, and then put these two bits together, you get minus 9 over 2. And then multiply back in by the 2. Multiply back in by the 2, you get 2 times x plus 1 to be squared. And multiply 2 by 9, minus 9 over 2, you get minus 9.
This is not x minus 1.
Sorry, it is x minus 1. Apologies. Yes. Thank God you're here, Emily. You always keep me on track. That's a good thing. Right. Okay, are we good? Right, okay. And then finally it says, hence or otherwise find the coordinates. Right, once you have it in, complete the square. The x term is the opposite to what's in the bracket, so it's plus 1. And the y is the same sign as what's there. Okay, which is minus 9. Again, we learnt that in algebra. Okay, you should have it nailed by now. Okay. 5, 10, 5. Oh, someone asked me something. Move it up, down. Oh, sorry. Right, are we good? Okay, overall, I thought you all did quite well. Yeah, good test. Right, if you nail down the logs, that log question, most of you would have done really well, okay? Right, okay, so last night's homework then, how am I going for time? Yeah, I'm fine. Right, last night's homework was on the product rule and the quotient rule. Right, okay, and I asked you to do numbers 1 except for part 1, numbers 2 except for parts 1 and 4, and then 4 and 6, was it? Yeah? Okay, anyone need me to do any bit of number 1? Anyone need me to do any bit of number 2? Three, no, did I give you 3? I did give you 3. Anyone need me to do any bit of 3? Did I give you 4?
Yeah.
Anyone need me to do it?
Yeah.
Yeah, do 4, right. So it says use the product rule to differentiate. Okay, so y equals the square root of x times 2x minus 1. Sorry, I'm magnified now. Right, okay, so it's a product. This multiplied by this. Okay, so you let u equal to the first term. So instead of square root of x, I'm going to write that as x to the power of a half. Is that okay? V is equal to the second bracket, and I'll call it 2x minus 1. Differentiate, call it du dx. Bring the power down in front, reduce the power by 1. So it's x to the power minus a half. Right? Here, dv dx, differentiate that, differentiate 2x and you get 2, differentiate minus 1, you get 0. Is that okay? So then the rule is dy dx is equal to u times dv dx plus v times du dx. So that means dy dx is equal to u is x to the power of a half, dv dx is 2, right, v is 2x minus 1, and dv dx is a half x to the power minus a half. Okay, will I multiply out? I suppose I better. Okay, right, I don't think you have to, actually, I know you don't have to, right, unless you have to use it, but look, it's good for us to multiply it out. So this is 2x to the power of a half, agreed? 2 by that. Right here, a half x to the power minus a half by 2x would be, that's, multiply the numbers, 2 by a half is 1. X to the power of 1 multiplied by x to the power of a half, what would that be? Or x to the power minus a half, it's add the indices, isn't it? So it's 1 take away a half is x to the power of a half. Do you all see how I've done that? I have a lot of puzzled faces looking at me, right? So I'm multiplying 2x multiplied by x, multiplied by, yeah, a half x to the power of minus a half. Okay, so 2 by a half is 1, and x to the power of 1, x on its own is x to the power of 1 by x to the power minus a half. You add the indices, so 1 minus a half is a half, so that's where I got that term from. And then I want to multiply minus 1 by that, so I get minus a half x to the power minus a half. Is that okay? Right, so that's 2 root x plus root x minus, I might bring this one back downstairs and make it x to the power plus a half, which is 2 root x. And 2 root x and root x is 3 root x, I'm running out of breath, sorry, 3 root x. Then it's minus 1 all over 2 root x. Is that okay? But as I say, in an exam situation, if you got to this line here, you get full marks. Okay? But the reason I multiplied out is probably this is what the answer at the back of the book looks like. And it's also good for us. Okay? Right? Yes?
It says to express it as a single fraction, is that?
Express as a single fraction, does it? Right, I need to get a common denominator, then I'm not finished. Okay? So, that means you do have to multiply out. Okay? Is it okay if I move it up? Is that alright? If I do that, have I cut you off? So put that over 1. So 2 root x is your common denominator. 1 to that goes 2 root x times, so it's 2 root x multiplied by 3 root x. And that goes in 1 multiplied by 1. So above the line, 2 by 3 is 6. Root x by root x is just x minus 1 all over 2 root x, and that's your answer. Okay, so sorry I didn't read it properly where I said express as a single fraction. That's, you wouldn't get full marks for the line I said so, because they told you to multiply it out and tidy it up. Okay, are we good? Right, that was number 3, that was number 4 even, and then number 6 was the last one, right? Okay, were you okay with number 6? Yeah. Okay, so number 6 reads the quotient rule. So y is equal to x all over 1 minus x squared. So you let u equal to what's above the line, you let v equal to what's below the line. So you differentiate above the line, you get du dx is equal to 1. The number in front of x is 1, there's a 1 understood to be there. dv dx, differentiate 1, you get 0. Differentiate minus x squared, bring the power down in front, reduce the power by 1, so you get minus 2x. Is that alright? Then the quotient rule is v times du dx minus u times dv dx all over v squared. Okay, so v is 1 minus x squared. Right, du dx is 1 minus u is x multiplied by dv dx, which is minus 2x. Okay, all over v to b squared, which is 1 minus x squared all to be squared. Is that okay? Tidying up on top, that's 1 minus x squared plus 2x squared all over 1 minus x squared all over 2, or all to be squared even. Right, up top I have x squared plus 1 all over 1 minus x squared all over 2. And they said show it's greater than naught. So basically show dy dx is greater than naught. Dy dx is greater than naught. That's basically greater than naught means show everything is positive. So if you show everything individually is positive, collectively it's positive. So is x squared positive? Yeah. Is 1 positive? Yeah. And underneath the line, it doesn't matter what that term there is, it's squared, so therefore it's positive. So if everything is positive, all the individuals are positive, everything is positive. So you'd write out sentences saying x squared is positive, plus 1 is positive, 1 minus x squared all to be squared is positive, therefore the whole lot is positive. I'm not writing that out, you can write it. Is that okay? Right? Are we good? Right, okay. Chain rule is next, girls, okay? Still this section, okay? Chain rule. Now, there is a rule, right? Okay, I don't like the rule, so I'm going to show you, right, how to do it, right, without knowing the rule. Because the rule, I find it easier to do it this way, right? I'm going straight to an example, right? Okay. Right, so if y equals 2x squared minus 1 all to be squared. Right, okay, so it's a bracket to a power. That's how you know you're in the chain rule. There's something inside the bracket to a power. Okay, so to differentiate, you differentiate the bracket first. Okay, so inside the bracket stays exactly the same. Okay, you bring the power down in front, so bring the power down in front 2 and reduce the power by 1. Is that right? So inside the bracket stays exactly the same. You're just differentiating the bracket if you like. So you bring the power down in front, reduce the power by 1. But now you must multiply it by, now you differentiate inside the bracket. So if you differentiate inside the bracket, what do I get? Differentiate 2x squared minus 1. You get 4x. So you differentiate the bracket and then you differentiate inside the bracket. So it's like the chain rule. You do a bit and then you do another bit. Okay? So we don't need to multiply out, but if you did, you can multiply the 2 by the 4x, which gives me 8x, and then you can multiply into the bracket if you like, but listen, you don't have to. I'll just multiply the front and the one at the front. I half multiplied it out. Right, is that alright? Okay, chain rule. I'll do lots of examples and we'll get a feel for it. Right, example 2. Y equals 3x minus x squared all to the power of 3. Okay, right. So what you do is you differentiate the bracket first. So inside the bracket stays exactly the same. Right? Okay. So inside the bracket, right, so dy dx, you bring the power down in front, which is a 3. You leave inside the bracket exactly the same. So you do it in steps. We do the bracket, and then we do inside the bracket. So inside the bracket stays the same, reduce the power by 1. Is everyone with me? Brought the power down in front, reduce the power by 1. Inside the bracket stays exactly the same, yeah? Now you differentiate inside the bracket. So differentiate inside the bracket, what do I end up with? 3 minus 2x. Is that okay? Now, we're not multiplying this out, but you can multiply the first term by the last term. Okay, so if I multiply the first term by the last term, I'll just get 9 minus 6x, and then you get 3x minus x squared, all to be squared, and you wouldn't attempt to multiply that out. No need. Right? Okay. Will I show you the common mistake? I think if I show you the common mistake, are you less likely to make it or more likely to make it? I bet you know what the common mistake is. Right? Common mistake. Don't write this down. Whatever you do, do not write this down. Do not, because if someone looks in your notes copy, I get fired because, oh my God. Right? Okay? So do not write this. Okay? This is what people do. Okay? They bring the power down in front. Right? Then they differentiate the bracket. And they reduce the power by 1. So they haven't done the chain rule. Right? Because you have to do it in steps. Does everyone see why that's wrong? Inside the bracket has to stay exactly the same. And then you differentiate inside the bracket. Okay? So, I'm going to give you a few of these to try tonight. Now, we haven't done many, so I won't give you many, right? But just maybe a few of the simpler ones, just to see how we get on. So we'll do page 284. Let's do number 7, which are just the straightforward ones. And number 8 has stickier ones. Okay, if you can't do them, don't worry, we'll learn it out tomorrow. But 7 you should be able to nail. Okay? Do you need a picture?